Hey, morning, Tim. How are you doing?
Good, good.
Oh, well.
Yeah, very well. How's it going?
Good. Not bad. Moving along.
Good.
Sunny day today. Can't complain.
Yeah.
Sessions going on now with class. Yeah.
Okay. Are you still going to work remotely?
Yeah, it's still remote work, man.
Ah, yeah. Yeah.
It never ends, right?
Yeah, true.
When you guys expect to open offices now?
We've been open. Intermittently, we do have some key meetings in the office once in a while.
Okay.
Yeah, it just depends on the schedule.
Cool.
Yeah. Good. Karibu sana.
Thank you. Thank you.
Yeah, Victoria, how are you?
I am well. Yourself?
Yeah, very well. I can also see Thomas, Marcy. How are you? Dennis?
Hi, I'm good.
Yeah, keeping well?
Yeah.
Okay. It's good to see you.
Yes,
Karibu.
Good morning, Tim.
Good morning. How are you?
I'm doing good.
Yeah. How's the going? How's the new gig?
Quite a journey. A lot to try and explore in the world of health analytics. Like I'm finding.
Yeah, at least you can say that you are reaping the fruits of data science. Yeah.
Data science. Yeah, exactly.
It's a good feeling.
Yeah, sure.
Yeah. Yeah. Good. All right. Phoebe, how are you? Hi, Phoebe. Alice, good.
Yeah.
Are you
Hi,
expecting?
Tim.
Karibu sana. How are you doing?
I'm good, thank you.
Okay, good.
Yes.
Yeah, who's still on the way?
I think Evaristo and Millicent will be joining us soon.
Okay.
Yeah.
You checked with Moses and Justina?
Oh yeah, sure. Let me check on them.
Let's check with them. Yeah.
All right.
Good. Yeah, just give me about 2-3 minutes, then we start. Hello? Hi, Victoria.
Hi.
Yeah, so how was the experience of the previous session?
It was
Did
good.
you like,
And
which was
yes,
the favorite topic?
I think pandas. I think I love pandas and linear regression.
Pandas and linear regression, yeah?
Yes.
Yeah, those are very key topics in data science. And, you know, pandas actually giving you a very good data preparation platform. Yeah. Any telco data that you've found exciting to work with?
I've just worked on data from work. I haven't gotten
Yeah.
to do any other.
Okay. All right. Yeah. Good. So you need to connect with the Tanvir. He's also in the telco. Yeah, Tanvir. You need to connect with him. He's also in the telco space.
Hi there.
Oh.
Yeah. You two need to connect. So I think,
Sure thing.
yeah. Karibu Moses, I can see, and Justin. Karibuni. Yeah. So maybe we can start with a round of introductions, because I think one of the intentions we have with this class is also to give you key networks that you can leverage on. So maybe just mention your name and then where you work and what your interest in data science is. And after that, I'll bring on the next stage, which will be to introduce the topic of discussion today. So I think we can start with you, Tanvir.
Sure. So I'm Tanvir. I'm a consultant at United Nations Foundation, but I have a background in telecommunications. I used to work with Airtel Africa. Right now, I consult with them for their data for development projects, immunization records, analytics, as well as health center mapping, and now in Mozambique, disaster preparedness. So I'm glad to be on board with predictive analytics with Tim. It's been a great journey, and I hope to enhance my skills and provide some insight to my engineers as well. That's it.
Yeah. Thank you. Thank you, Tanvir. We look forward to having a lot more depth in the foundational skills that we had in this course. Yeah. Then Victoria.
Hi everyone. My name is Victoria Nganga. I am a telecommunication engineer by training and also working. I'm currently practicing with Airtel. Yeah. So I just finished the introduction to data science. I think our last class was last week. I look forward to more engagement, and I really want to get involved in data science in the future. Yeah, so I look forward to an interactive session.
Yeah, thank you, Victoria. Yeah, so we look forward to adding value to what you do at Airtel. Yeah, Dennis.
Okay, so good.
Oh, there are two Dennises, so whoever talks first.
Okay,
Yeah, Dennis
my name is Vienna. I do just stuff. I do just spatial analysis, data collection, and remote sensing as well. And I'm happy to join you.
Karibu sana, Dennis. So we work with Dennis. His specialty has been on building of GIS platforms. Now he wants to go deeper into ML, and we'll want to see how to automate some of the GIS stuff such as satellite imagery, weather predictions, agricultural and climate change. Karibu, Dennis. So Dennis 2.
Okay, thank you. My name is Dennis Kevogo. I'm the lead data scientist at Smart Applications International Limited. So currently, my area of investment in terms of data analytics is healthcare analytics, specifically predictive analytics, let's say in detecting fraud in claims processing. If there is a fraud in terms of the claims or not. That is some of the aspects that you're going to invest in terms of predictive analytics in healthcare, and many more, which I'll get to share in the course of our journey.
Yeah, Karibu Dennis. So Dennis has been one of us, but we recently gave him an opportunity to work in the main industry. So he'll be taking you in the neural networks and some other machine learning models, very key in analyzing image, video, and voice analytics. Yeah, so we look forward to that. Karibu Dennis. Next is Phoebe.
Good morning.
Good morning, Phoebe.
My name is Phoebe. I work at KCB, the finance department, as an analyst. Yeah, and I just want to learn more. Yeah, that's it.
Thank you. We look forward to giving you a lot of tools you can use in the financial analysis space. Karibu. Mercy, it's your turn.
Hi, everyone. Mercy Kimani here. I am a senior data executive at Dalberg Research. My very big interest in this course is to be able to add analytics in the sense of consultancy in terms of governance and strategy.
Yeah.
Thank you.
Thank you for that. And so Mercy has been with us in the introductory introductory module. Yeah, so she's advancing herself, and she works with a research firm, Dalberg. They do a lot of work in research, so very deep in the analytics space, doing things like census analysis, building economic models. And we look forward to having you on board, Mercy, and we hope also to be able to share some of the insights that you as Dalberg have that can be enriching the other professionals in this group. Karibu. Next is Thomas.
Good morning, everyone.
Good morning, Thomas.
My name is Thomas Vienna. I work with chloride oxide as a statistician, stroke demand planner, and I have key interest in data science, especially to enable us to get accurate forecasts on our products, especially the imports and what we manufacture. Thank you.
Thank you. So Thomas, chloride oxide, if you have a car, you use his products. So his interest is to know right now, for example, because of COVID, you've parked your cars at home, you're on lockdown. Well, what does it mean to his distribution? So he's very keen to learn about distribution models, tracking consumption of behavior. Yeah, and then, so Thomas, maybe just out of interest, are you getting a lot of jump-starting the batteries? Most of the batteries their lives are reducing because people are not moving around. How is it like?
Yes, we are getting some cases, and we've done some marketing initiatives whereby we tell our customers to at least start their vehicles and move for at least once or twice in a week, so that the batteries do not go into a state of condition. Yeah.
But from a business perspective, have you seen a surge in demand for batteries when the lockdown was ended?
Actually, for us, the sales are unexpected. They've actually grown.
They've grown.
Yes.
Yeah, it's very interesting that some markets you'll assume that but because the cars are not moving, batteries are dying. Huh?
Yeah.
Yeah, that's interesting, man. Thanks.
Yeah. So actually for us, COVID has not really affected us. And we are looking into growing the business and getting more, because actually the imports are not coming in. So for us, we are taking advantage of that.
Or the imports are not coming in from China?
Yes. Yeah.
I get it. Yeah. So those other alternatives are not available. Okay.
Yes.
Yeah, that's good. That's good. At least some positive news and the COVID side of related impact on the economy. Yeah. Thanks for sharing the insights. Yeah. So, Justin, it's your turn.
Good morning, everyone.
Good morning, Justin.
My name is Justine Murenzi. I'm not working at the moment. I just want to focus on data science as my career.
Yeah.
Thank you.
All right. Karibu. Justin has been with us in the introductory to data science. Justin, by the way, you know you have a lot of projects. Why don't you come up?
I'll be happy when you give me an opportunity.
Let's talk after this, yeah. But we have a lot of projects which are going. We need extra hands, huh?
Okay.
Yeah. But thanks for joining this. So this is going to actually cement your confidence in the data science realm, and we hope at least to open up more opportunities that you can leverage on and get to get what we call ROI, return of information. Do you know what return of information is? Dividends. Yeah. So you get to have some benefits of the information that you have. So you invest in education, and then the education is supposed to have some return in terms of monetary value to your investment. So we call it ROI, return of information.
Okay.
Yeah. Karibu sana, and we look forward. So let's talk. I think we can talk in the afternoon after this session.
Okay.
Yeah. Moses, Karibu. You're muted. Okay, fine.
Hello, everyone. How are you doing?
Hi.
Happy to see Tanvir joining us.
Yeah. Okay, reconnected.
I need him to share one of the teddy bears. Come for one.
Yeah. So when did you guys interact together at Microsoft?
We worked with him in Airtel. So
okay, Airtel. Yeah.
Yeah.
Good.
So yeah, I have a telecommunication background as well as IT background, but at the moment I'm doing sales. So I sell anything that can be sold.
Yeah. On tech side of things, eh?
As long as it's legal.
Legal, yeah. Thanks.
Yeah. But if you have a lot of interest in data science and AI as well as machine learning, I'm doing my doctorate. So I'm focusing on security related to AI and machine learning. So this is of great interest to me to learn.
Yeah. Thanks, Moses. Moses actually works at Oracle. Maybe what can you encourage? Because Oracle is a leading technology provider, and maybe you can just encourage the class here. You know, you went through our introductory program. How do you see the skills that we are giving vis-a-vis the demand for those skills from a technology perspective?
The skills for data science are really in demand, especially if you look internationally. I worked previously last year with Microsoft, and it was very hard getting local skills of data scientists. And I spoke with one of our general managers. He was called Cebu, who left for the US. And he actually told me there was a lot of demand and there was lack of skills, even globally, even actually in the US. If you look at the data science jobs in the US, actually you'll find there are very many. There are like maybe in the tunes of 30,000 available jobs. So the jobs are there, especially if you're young and you feel like you don't mind leaving the country, you want to go in the US or Canada. I think the opportunities are very many.
Yes.
And also locally, I believe there are also many local jobs. I have a friend of mine who was working at Microsoft at the same time working for the UN. So you'll find a lot of jobs that you can actually do. Yeah.
And actually, now that you mentioned about that opportunities, I think I saw an announcement by Trump just last night saying that he's changing the immigration bill. And now for you to go to the US, it will be based on the skill set that you have. So it's good to note that actually there's a deficiency in the skill gap. And data science is one of the most sought after skills. So maybe if you're looking at migrating to Canada or the US or Australia, this is actually a free pass for you. A free pass for you.
That's true.
So thanks. thanks for sharing, and that's encouraging. So just to encourage everyone in this group, it's really not a skill that confines you to the tech world, but I think outside, in the outside world, there's so many applications, and you can use it to leverage an opportunity that comes across. Yeah, and then looking at the future of it, that's where we are headed.
Yeah.
So we have thanks a lot, Moses. Yeah, so we can have the two last ones. That's Nelly and then Evalisto.
Morning, everyone. My name is Nelly.
Morning.
I'm a data analyst intern at Wimedia, and I'm here to learn and get more information. Thank you.
All right. So yeah. Thank you, Nelly. So we look forward to having you at a lot of media applications. There's actually an article we published yesterday on our blog. We'll share the link about data journalism. I think a lot of use cases which have not been explored so far in that front. So we look forward to having you on board and transforming your skills in analysis. Yeah. Lastly, Evalisto.
Good morning, everyone.
Good morning.
My name is Evalisto Murugi. I work at KCB in the marketing department. I'm a brand manager for all our mobile banking products. So when you talk of KCB M-Pesa, you talk of KCB Mobi, and now the new kid on the block, Vuma. I know most of you have seen us in the media, and also on billboards in Nairobi specifically for the product Vuma. Then I'm the one who handles that from a marketing point of view. I'm here to learn. I found
that. Just tell us about Vuma, a pitch. Use an opportunity for you to tell what you do.
Okay. Actually, Vuma is a mobile. What we will call it, a mobile money wallet. Yeah. Which almost, if I could compare apples to apples, I would say it's a direct competitor of M-Pesa. But then the uniqueness of Vuma is in the fact that you don't need to be a Safaricom a customer only, but you can access it on all the three service providers. That is Safaricom, Airtel, and Telcom. So it's accessible via an USSD, *844, and there's also an app for it. Wow. So basically, all the products that are on M-Pesa, you can still get them on Vuma.
Wow, that's interesting. That's very interesting. And I think we still have room for innovation and competition.
True.
Yeah, and Safaricom has not sued you.
It's a competitive world, and it's open for everyone. So we need to not even to fight each other, but to make sure that the customer gets value for his money. Yeah.
And are you going to launch your own telco network?
No, not yet.
Okay.
Not yet. Yeah.
That's going to be an interesting one to watch, because I remember Equity launched Equitel specifically for a SIM card, and that SIM card, their license was withdrawn because the Communication Authority realized there's no one making phone calls on Equitel. They're just using banking transactions.
True. It had issues, yes. But the direction we've taken is we're saying we don't need to provide telco services. What we need to do is to provide financial inclusion. In the sense that, you see, Safaricom can't do lending because they are not a bank. So and that is why you will find KCB M-Pesa and M-Shwari. They've partnered with banks. That is KCB and NCBA, and also the Fuliza. They've also partnered with banks. So what makes us go into this is we are a bank and we can lend. So we don't need partnerships. And at the same time, you're saying, looking at the cost, then most people have really complained about being very expensive to send money to withdraw. So what you're saying is, once you are in the ecosystem, then it's cheaper and you can do everything. So you can transfer money from your account to your Vuma wallet free of charge. Then do all that you can do. For example, if you need to buy tokens, KPLC tokens, then you're saying it's free. So you don't need to send to M-Pesa to buy and be charged.
Yes.
Yeah.
That's a very interesting to watch. Competition is real, eh?
Yes, it is. It is.
Yeah. Okay.
I'm really happy that I went through the first intermediate, or not intermediate, introductory bit of data science.
Yeah.
Then now this intermediate one, I think it is just to unlock that potential in that industry.
Yeah.
In the data science industry, being a marketer, I look forward to it giving me an edge in doing analytics of the marketing matrices that we do, the campaigns that we do out there. You don't just need to do a campaign that it's not targeted. So I think data science will give me that edge in knowing that I'm investing here, and this is the return that I need to get.
Yeah.
Yeah.
Thank you.
And just maybe to add on it, I've seen my industry, that is my company, has consolidated what we call in the strategy department a section for data analytics that will be used mostly in tracking a customer and knowing his profile from the day he entered the bank to where he is, and using maybe targeted communication and the cycle where he is in the journey in the bank, and then you do you pitch different products.
Yes.
Different products based on where he is, and his income levels, and specifically the behavior around that customer. So something like limits for mobile banking. Then they will be done by data analysts. Depending on the behavior of this customer.
The behavior. Yeah.
Yeah.
Yeah, so I think those are very critical use cases, and it's all leverages around availability of data. So we'll be looking at how do you mine that information. Yeah, identifying the business problem to be solved, very critical. As you say, you already identified, which is customer lifetime value. How do you track a customer's life and being able to provide different offerings along that life, which is a very big case in banking. One of the biggest use cases that banks are approaching us right now is called pre-approved loans. So banks are coming to ask us now, because customers are not coming out to apply for loans. Can we be developing a model that can predict this customer is approved for this kind of loan? Then you send a link that tells you, fine, can you click here? You get a loan of 2 million, Bob. You've been pre-approved. Yeah. Yeah. So we look forward to having that value addition. So, and we'll be also having coaching. So I'll need to speak to each of you individually to see what your career growth plans are, just to prepare you, because something has to change. What I call ROI means there has to be value in your investment. So either it's moving to a new department, getting a promotion. You can also quit and set up a consulting. There are many options. So I look forward to guiding each of you into that journey of creating excellence in your careers. Yeah, so thank you all for the contribution. So as I said, this level of data science is less coding, more business applications. So we'll be having a lot of such conversations which are life-based and business applications. So at least we can be able to heavy lift and transfer most of the knowledge that we have in the tech side into the business application. So I wanted to introduce today's topic. And as I do that, there's a platform that I wanted us to use. So I'm going to share a link on the chat, or maybe I'll share my screen and then I just ask you to, I'll do both. Let me just type here, P. So I've shared that link on the screen. Please click on it, type it on your browser. I'm hoping you're all using laptops. If you're using a phone, then it's going to be a challenge. Anyone who's using a phone? So just in terms of administrative announcements, we have new platform for exams. So Alice will be checking with you, each of you, to ensure that you've set up that exam. We also have a platform for resources called 4IR. So Alice will also be checking to see that you've set up. And for the new students who didn't take part in our introductory course, we have a platform called Lab.Predictive Analytics, which has got a lot more enriching resources that we look forward to you downloading. So let me go ahead and show you the platform here. So we'll do lab. Sorry, this is IPP. So this is our ML engine. Of course, it skipped a step because I already logged in. So what I'm gonna do is allow the screen sharing, and then I want to guide you to set up an account. So who has been able to log in?
Yeah, I'm in.
I have.
You have? Victoria, you're good. Who else?
I'm in.
Okay, Thomas, good. Yeah, you can also type on the chat if you've joined. Phoebe, Nelly.
I'm in.
Okay, good. So I'm gonna enable screen sharing. I want to use one of your screens to guide you. So who's willing to share their screen?
I can share.
Yes, please, Nelly, go ahead.
Yeah.
Good. Yeah. So as I mentioned, this is a ML, machine learning platform. So we use it for deploying large-scale analysis of massive data sets. So we have different modules in it. So we have a HR module, we have an economic data module. Scroll down. Yeah, Nelly, you can scroll. So my internet is unstable. Yeah, so Nelly, you can hear me?
Yes.
Okay. Yeah, so what we've done with this, the backend is built on Python. Yeah, so there's various stages that each of these data analysis steps take. So what you did in the introductory data science was all the 3 levels of data science. So I'm gonna show you how the end product will look, because at the end of the day, you're not gonna share with the business users a Python notebook. No, you're going to share them an easy to use interface for them to be able to make decisions. So let's go back now to the top. So I'm going to use this example to demonstrate to you the topic of today, which is the data science lifecycle. So let's proceed with the HR module. So what I want you to do, Nelly, is can you click on download test file? Now, in this particular case, we were challenged to develop a system that can be able to predict the next employee to leave an organization. So, yeah, what happened is there was a high attrition rate in the company, and then most of the challenges that the HR were experiencing was spending too much time doing interviews to replace the staff. So the attrition rate actually ended up being 25% attrition rate. So that means out of every 100 employees, 25 were leaving every month, which is a very high attrition rate. So we developed an investigation to be able to determine how the most accurate way to predict who is the next employee to leave. So Nelly, if you can scroll down just to see how many rows and columns are in this data set. So you can see the rows and columns. We have 8 rows, 8 columns, and about 15,000 entries on the column. So this data set contains 15,000 employees. So Nelly, I want you to save it on your desktop, somewhere where it's easy to retrieve.
Okay.
And, yeah, so the rest of the class you can do the same as well. Just don't change the format, just save as a CSV file. I see you're saving as Google Sheets.
Google Sheets.
You need to save it as a CSV.
Again.
Yeah.
No.
So have you saved it?
Yes, it's saved.
Okay, so can you proceed to back to the module where it was written, proceed. Go back to the HR module. Yeah, so click on proceed. Yeah, now check on file, click on file, and then select the file that you just saved, which is there. Okay, so click on upload. Then click on analyze. Show that the extension. Sure, that was the power extension. Yeah, so it's analyzing that data. So as it's analyzing, you can click on the drop-down menu on the HR module. Just click on it, give it time. Go. Yeah, drop down. See the HR module, that drop down. Yeah. So this is the data that is in this kernel. Yeah, so if you see the average monthly hours, the total monthly hours an employee was working. We have the department, so the type of department the employee worked under. Yeah, so we have departments such as sales, accounting, HR, technical support, management, product management, and marketing. Where we have evaluation. Yeah, the employee's evaluation score in percentage. We have project count, the amount of project count an employee has done. So I hope each one of us has been doing this exercise. Who has finished executing? Are there graphs appearing? So you can scroll down.
Yes.
So Nelly, yours is not appearing yet. Whose is appearing yet? We can. So maybe the internet connection is slower, but it's still gonna come.
Mine has appeared.
Please share your screen. Who's gonna share the screen? Was it Moses? Okay. Thomas, good. Yeah, so this is how the module will execute once it finishes running the model in the background. So as I said, this script was developed in Python, the same Python notebook that we've been using to analyze data. So I'm gonna walk through this step by step here. So You can scroll down again, Thomas. So you see, this is what we call EDA, Exploratory Data Analysis, just trying to look at different dimensions of the data. Scroll again. Salary by department, we are using different, so this is Seaborn. We are using Seaborn map to create these charts. Seaborn matplot were used during this project. Yeah. And these are very interactive. Maybe just try to move the cursor around the graphs. Yeah, you can see the variations. Yeah, scroll again. Yeah, salary of those who stayed versus those who left, again, you can see. Yeah, scroll. So we're able to utilize different types of charts. So remember, there's a module we studied around data visualization. Yeah. Victoria, has yours rendered?
Not yet.
Sorry?
No, mine has not yet executed.
Do you have a firewall on your machine? Are you using the work computer?
No, I'm using my personal computer.
So maybe check on your internet connectivity. You can just restart. Yeah?
Okay.
Yeah. You can just restart a different, you can open a new tab. So who knows the name of this chart that's displaying here? Anyone? Anyone has come across it?
Chat box or something.
Sorry, again?
Chat box. Chat box.
Yeah. It's a good try.
Give you an idea. I could help him.
Yes, just give an idea, a clue. It's a music instrument. Which music instrument looks like this?
A violin.
Yes. This is called a violin chart. Yeah, so Thomas, try to move your cursor around. Yeah, you can see its function. It shows you the mean, the median. You can be able to use it to measure the distribution of spread for any data set. And you can see those numbers changing. Okay. So Dennis, you might want to explain mean, median, standard deviation from statistical.
Yeah,
angle.
sure. It's okay. Okay, fine. So one, talking about the mean, we have, that is the mean salary distribution. Maybe if we have a mean of 0.45 in this case, and then mean is simply the average, that is the average salary distribution. And then we have the median. The median is the value of the salary that is at the middlemost. That is the one within it's at the middle. That is the best explanation. So if we have the highest salary and the lowest salary, so the one that is at the very middle, that is our median. Then the max is the highest, at the highest value in terms of the salary. Then the minimum will be the minimum value. Yeah, I think we have the median, the mean, and then if we had the mode here, although I can't see the mode would be the value that appears the most.
Yeah. So thanks, Dennis. So just when you look at this chart, without even asking yourself many questions, you can see management has got almost a standard salary. There are no bubbles. So which means, for example, if you look at sales, what does it mean in sales? Where are most people? So in sales, you mean most people are at the bottom. So most people are not earning a high salary. So it's when you look at the bubble being at the bottom, it means that's where the majority of the employees are. Yeah. So we can use it even to distribute. You can check on the customer distribution in terms of what customers spend. Yeah. So different products versus how much each customer gives you. So you'll see that if you have got a cash cow, the bubble will be on top. So which means most customers are spending a lot. Yeah. For a dog, yeah, which is now a problem in our brand. most customers will be at the bottom, so which means they're not spending a lot. Yeah, so that's how you interpret this chart, and we'll be looking at it also, the business data science life cycle. Let's move to the next one, Thomas. Yeah, so this is where now you start doing more analytics, more predictive analytics. So this is where we call correlation, test of correlation. So we use the linear correlations, and this is a heat map. I saw you doing a lot of it using a Seaborn on a Matplot, and I'm very happy that at least you have got a good appreciation of how to interpret such a chart. Moses, you might want to interpret this chart for us.
So this is showing I believe the correlationship between. Hello, can you hear me? Hello?
Yeah, are you there? Yeah, you can.
Can you hear me?
Yes, we can. Yeah.
Okay. So definitely this. Can you hear me?
Yes, yes, we can.
I'm trying to remove the echo. So I believe this is showing us the correlation between the different attributes we have.
Yes.
And where it has a deep red, this shows, I think, the highest correlation.
Oh, you've lost you a bit.
What I'm saying is where it shows a deeper red.
Okay.
Or no, sorry, I think the deeper blue shows the highest correlation.
Okay.
Yeah.
Yeah, you're right. So in a business interpretation, what can you observe? And then we'll reveal the results down there under summary.
So we can see
give a guess?
Left and satisfaction levels have a high correlation.
Mm-hmm.
And the action level and the left have also a high correlation. And where it is probably the deep red, it has the least correlation.
Oh, I don't know if it's on my side, but I appear to be losing you. It should be on my side. Let me just change my connection 1 minute. You can. I'm changing my connection, so I might.
Okay.
Yeah, so sorry, I'm back. Yeah, can continue. You had explained that.
So I was saying where it's a deep blue, it's where there is the correlationship, like for example, between the left and the satisfaction level is a high correlation.
Yeah.
And and probably where there is the deep red, there's probably no correlationship. That's what I think.
Okay.
Yeah.
Yeah, you're right. So there's a high correlation between different entities. For example, employees who left had a less satisfaction. So when you check a less satisfaction and left, you will see it appearing to be a dark figure. So when it's dark, it means that's a problem. Yeah. So in a positive correlation, means, for example, evaluation versus the promotion and salary is high. So when you score high on evaluation, you get a promotion. Yeah. So let's move down to look at the summary. So when you look at the notebook, a Python notebook, you'll be doing this and you'll be writing this in the markdown cell. But now for this system, it analyzes and gives you a recommendation. So any business user, even the CEO, who doesn't know how to interpret a heat map, when they read this, they can be able to see. Yeah. So you can see, for example, from the heat map, there's a positive correlation between variables. count average monthly, which means employees who spend more hours, did more projects, and higher evaluations. Then there were negative correlations as well. And it doesn't just stop there, you also give conclusions. So what are the questions you're asking yourself? So what features affect your target variable turnover the most? What features have strong correlations with each other? And can we do a more in-depth examination of these features? So during the data science life cycle, now we'll be moving from the EDA, now we go into feature engineering. Now the feature engineering is where you start testing hypotheses and building a model and testing using the machine learning models that you learned. Yeah, so I'll be showing you that now in the next presentation, but Thomas, just scroll down so that when I refer back to it, you'll know. So this is further analysis, just how many guys had accidents. Continue. Yeah, so this is a feature importance. What features are most important? So we use decision tree classifier, the DCT, to be able to create which features have got highest rank of importance. So for example, here satisfaction level was considered to be of priority, and then followed by number of projects, and then followed by number of years worked in the company. So you can scroll and look at the recommendations. Yeah, so by using the DCT classifier, it will rank the features used in the prediction. The top 3 features were employee satisfaction, years at company. So this is helpful in creating a model of for logistic regression because it's more interpretable, to understand what goes on in a model when you utilize less features. Yeah, so there's a module we'll learn about DCT, decision tree classifier. So we'll be going deeper into it and seeing its application. But from the data science life cycle, I want just to show you where it sits. Yeah, go again. So you've separated, then you go and test salary and turnover. You can see it's been able to extract the features who are important. Then go to the next one. So again, scroll. There's one that I wanted to show you at the very end. Yeah, so that one. Yeah. So this one we use, it's a clustering algorithm. Yeah, so we can use the KNN or we can use the random forest classifier. The KNN, which is K nearest neighbor. You can see the parts in orange here and the parts in blue. So the parts in orange, these are employees who left. Now, from a visualization perspective, you can actually see a pattern. Yeah, so when you use one of these models, KNN, you can be able to see clusters of employees who left around certain areas. And because we use DCT to identify satisfaction and evaluation as the most important features, now when we map satisfaction versus evaluation, that's when you see the clear correlation. And this is how you do a prediction. So K nearest neighbor means anyone in the neighborhood of this orange is at the risk of leaving. And each dot here represents an employee. So these are like 15,000 dots. So when you're trying to predict which employee will leave, it means when you click on an individual dot, like for example, when you go on the right-hand side and you see this cluster of many oranges, you click, these guys inside here, they're as good as gone. They're just waiting for an offer to come from somewhere and then they quit. Yeah. Or they're just hanging around because they're waiting for some deal to happen. Yeah, maybe they're waiting for their commission to be paid, but they're as good as gone. So this is how you do a prediction. And it's something that I wanted to just show you in terms of a real application that really works out there, that can be used in the business world to make decisions. So this particular module is critical for today's lesson. So I'll encourage you to make sure that you go through it step by step. We also have a Python notebook that developed this available. So scroll down towards the end. So these are the recommendations that you can give to the business. Yeah. Conclusion. Okay. Yeah. So you just see data science is not just about analyzing and using algorithms and funky charts. It's also about creating predictions that are able to provide a business recommendation. Yeah. So it means that you have to immerse yourself in the business world, getting to understand the context, building models, getting to appreciate what features of an algorithm are the most important one to be determined when building a model, being able to interpret the results, testing the hypotheses, looking for what we call the true positives, false negatives, because those also have got an impact on the accuracy of the model. Yeah, so we'll be looking at those step by step. So thank you, Moses, and for taking us through the interpretation of the charts, and then also Thomas for sharing your screen. So any questions on this part? Okay.
Hi, team.
Yes, hi, Moses.
Yeah, I was trying to log into the link you sent out. I don't know why it doesn't respond. When I click on to log in, it just...
Okay. When you click on
nothing,
login.
Yeah, nothing happens.
Do you have a firewall?
I don't think so.
Okay. What you do is try to use a different browser. Maybe if you're using Chrome, you can try use Mozilla or Safari.
Oh,
see if it can respond. If and then if not, maybe we can try a different option.
Okay, it's okay. Let me just start my PC and see.
Okay. Yeah, so yeah. So I think Dennis can help you on the side. Dennis, you can help Moses.
Okay,
on the side chapter.
Okay, sure.
Thanks. All right. So I'm gonna share my screen now, and we start on the side. So this is what we call the data science life cycle. So I'm gonna give you some time to just reflect on the other side as I grab. So we can just do a 2-3 minutes break, grab some water or something, and then we come back to resume. Hello, so we are back. So I hope you've all settled back. Good. So in the next 1 hour or so, we are going to look at the data science life cycle. And then after that, Dennis will take over with the introduction to neural networks. Yeah, so we'll be introducing that topic. And then we can, yeah. Okay, so So welcome back. So as I've shown you now in the different, in the other script, which is a real life application of our Python model is deployed. So this is now the science behind it. So I wanted just to, the next few minutes, be able to share to you step-by-step procedure of this data science life cycle. Yeah. So in order to make a life cycle successful, it's important to understand each section. Yeah. Well, so, Marcy, you can mute. Yeah. So specifically, it's very important to understand the difference between the development stage versus the deployment stage. Yeah, because what we've been doing mostly now is developing. We can be able to build models on a notebook, but we're still not able to deploy the models on the web so that to have more users using it. So I'll be showing you those steps and seeing which skills you will need to gain so that you can be able to excel in each of these stages. Yeah, so most data science projects have similar workflows. Yeah, so what I've shown you on the HR one is the same one which we used for predicting credit scoring. It's the same one that we use for customer churn prediction. So those outputs and models are almost the same. Yeah. So we're going to look at this life cycle. This is how it's visualized. So the same thing that you saw on the Excel, I mean, sorry, on the dashboard that we went through, these were the steps, okay? So if you look at the first step here, it's a problem identification. So I want to use someone within the team who's got a real problem to solve, and then we can walk the steps together. So who can volunteer? I'm looking for a volunteer. Yeah, who can start us off? Any problem that you have in the business that you like to solve, we can walk through these steps with you. So how do you identify a problem to be solved, for example?
Hi, team.
Yeah.
Maybe I'd suggest a problem.
Yes, please go ahead.
Say in mobile loans industry, how would you predict the people who will default on payment of their loans?
Okay. Yeah, so, but that's Evalisto, eh?
Yes, this is Evalisto.
Okay. Yeah, so how do you create a prediction of a default on a credit scoring? Yeah, so of course there's one module in this section of data science that we'll be learning about loan default prediction. So what is the type of data will you need? So once you identify that problem, one of the key identifiers for it will be KPIs. Yeah. So there's something we call banking KPIs. So loan default rate is one of the KPIs of data. Yeah. So because now I'm giving you tools that you're going to use in the day-to-day work. So I'll be going offline. So let me show you a tool that we use for that. I'll share my screen here. Just hold on. So we use KPIs to track which problems to solve. So let me share my screen now. So for example, this is you can see this. So you have all this available for you at your disposal. So this is for finance KPIs.
It's not displayed on the screen.
It's not displayed?
Yeah, from my side, I can't see it. I can just see it as like a small box down at the right corner.
How about now?
Not yet. I don't.
So what I'm doing is I've dropped the link on the chat. You can click on it. So we use this to track finance KPIs: revenue growth rate, net profit, gross margin, net income. Now, if you fall below a KPI, then it means there's something you need to investigate. Let me drop another one. This is for customer KPIs. So how do you track customer performance? Anyone else who's having the same problem? You're not able to see the screen? Are you able to see it now?
Yes, I can.
Okay. All right. Okay, so yeah, so this is what we call an NPS score. Yeah, so this could be also a way of analyzing if you're falling short of your expectations. Yeah. So a key area of also managing expectations. So I want you to spend your time looking at this. We also have another one here called KPIs, which is for employee performance. So for example, the previous exercise that we did, the KPIs that we were tracking came from here. So for example, employee churn rate. This is how it's calculated. So when we figured that employee churn rate is 75%. So number of leavers, the number of employed, 100, 1,000, compute. So this is a bug. Yeah, but it gives you a percentage of the number of employees who have left. So then if there's always an accepted normal. If the employee churn rate is more than 100, is more than 10%, then it means there's a problem that you need to solve. Yeah. So you can also measure absenteeism. Yeah, there's a formula for that. You can do 60 degrees feedback. There's a percentage for that. Human capital added value. There's a percentage for that. You can calculate. Yeah, the indicator. Yeah, a measure of the extent to which employees add value to the business. Yeah. So as a data scientist, it's important to know which business problem you're trying to solve, because that's where the business really needs your impact and input. So after identifying the business problem that you're trying to solve, you come to the business understanding. So are you able to relate those KPIs, yeah, to the business output? Yeah. So for example, on the problem of loan prediction, yeah, what is the key dynamic driving the loan prediction? So is it because of, for example, COVID? So most people have lost their source of income, so they're able to delay their loan payments. So how do you recalibrate your loan, the loan model, so that you can be able to take into account? Then we've got the next step will be the data acquisition, which is extraction, transaction, unloading, transforming, and loading. Yeah, so you acquire the data. So once you know the business understanding, it means either it's finance data, marketing data. For the loans, you know exactly you'll be getting your loans, the data from the CRB. You need information from the bank statement. You need also to do assessment, any collateral that the loan applier has. How do you get that information? So after doing that, you move to the next step, ETL. So in the ETL stage is where now you start doing the cleaning. So that's where your pandas and NumPy come in. Yeah, arranging the rows, columns, clean, removing any non-available numbers, trying to identify any outliers and treating them as such. And that will prepare you for the next stage, which is the data understanding, the exploratory data analysis. It's called EDA. Yeah, so at this stage is where we do visualizations. So lots and lots of visualization using the different maps. Yeah, so you can use bar charts, histograms, scatter plots, violin charts, and any other charts that you consider helpful in your decision exploration. Then after that, you move to the next step, which is feature engineering. The feature engineering, this is where you start doing the test of hypothesis. Yeah, so you work with, for example, 5 different algorithms. Linear regression is the one which is used mostly. And then we have KNN, we have random forest, we have decision tree classifier. So you just test, nothing restricts you from testing, okay? Then after that, you move to the model creation and training validation. So this is where you do your false positive and false negatives. So which of the prediction is most valid? So between feature engineering and model creation, it requires a lot of science. This is where we call model recalibration. For example, if you predicted that, a model predicts that client X is going to be given a loan, okay? And when it's given, actually it doesn't pay back. Yeah, so that is what we call a false negative. So the results, it's called true negative. So the results of the model were true, but the output was false. So when you look at those kind of calibration, that's we use models. We use concepts such as the area under curve. Yeah, there's what you call receiver operator characteristics. They come in very critical when you're doing your model calibration. Then after that, you move to the model deployment. Yeah, in the model deployment, so we talk about other skills. So you've heard about Django, Flask. Now there's a new platform that we use for deploying on the fly, on the edge. Yeah, so you can use, for example, Firebase. Yeah, for example, the platform that you are using is built on Firebase, and the model is a Django. So the deployment was done using the models built on top of the Django framework. Yeah, so we'll be showing you a little bit of this deployment. The learning curve is steeper, but we'll introduce you to at least creating some simple deployment models using some key frameworks and using actually the notebooks that you yourself will have worked on to solve a real business problem. On this side, we've got data drift analysis when you're doing your deployment just for testing and using other, checking with other users. There's also model monitoring, again, to monitor the performance of the model, because nothing is perfect unless the rubber hits the road. For example, we got the self-learning algorithms, which are used for self-driving cars. So these models are still being learned, they're learning. So when you deploy a model, they'll take time to learn and adapt and create more accurate predictions. So for example, Tesla cars have got those ML models using deep neural networks. Yeah, so that's why we call them self-learning, because they mimic the human brain, they learn with time. So just know that any model that you deploy will take time to be tested. You can test it manually, yeah, or it can be machine learning where the model is testing itself and becoming more accurate. Yeah, so that takes time, and we call it model tuning. Then the last bit here will be a dashboard, reports, and scores. So for example, Alistair's case for predicting the loan book portfolio, that will be a credit score that you'll be issuing. For the one that we were doing for predicting an employee who's about to leave, it's a report, that's an output. You can have a dashboard, for example, that can predict the weather pattern, or recommendation engine that's to predict where to open a business. Yeah, so the output of this can be different. So you can see how this loops back, yeah, back to visualization, which is again is under EDA. Yeah, you can see how the model monitoring can loop back to data acquisition, because it means you're going back to the production logs to collect more data and throw it back here to make better predictions. Some of these models require more data, yeah, than for them to run more predictions. So we go back to the production logs to get more data. Feature engineering, again, you can look at updated features, yeah, so finding features which were not working before. In training, yeah, so doing your 20-80% training calibration, keep training, keep seeing, keep fine tuning and playing with the parameters to ensure that you get the right mix of a prediction. So this is how the life cycle looks like in a nutshell. Yeah, so under each of these key steps that needs to be followed, and I just want to take you through the key highlights, yeah, for each of them. Yeah, so I've already explained about the model development stage, yeah, and then of course the right-hand side represent the model deployment stage. Yeah, so you see the development stage on the left side, then on the right side is the deployment stage. So what we've done in the introduction to data science was mostly up to the development, feature engineering. Yeah, but now we want to pick up from there, going to model creation, model deployment, model monitoring. Of course, we'll be referring back to pandas, numpy. Yeah, so any script that you'll be writing will start with the EDA, import pandas, import numpy, import SNS, import Seaborn, and all so forth and so forth. So at the production stage, what are the key things you need to take note of? So clearly identifying the root cause of a problem, we already agreed. Developing a detailed problem statement, yeah. And then how do you identify the problem? I've shown you the KPIs where you can go and identify the problem. You can also talk to the stakeholders, get information from them. You can merging existing research and information from your stakeholder and offer some insights. And then also literature review, yeah, by doing research to understand, get the problem deeper. So as data science, again, I need to encourage you, you need to be doing a lot of reading. You need to be subject matter experts. This one we've learned the hard way. Just yesterday, I started my day with a meeting with a telco company. At midday, I met with a bank. At 2 o'clock, I met with a distributor. At 3 o'clock, I met with a manufacturing company. Yeah, and then at the end at night again, we had a session with a health insurance company. So these are the kind of variations that we see in terms of how diverse your skill sets and understanding of the business problem will be. So you're not an expert in each of those fields, but you need to, when you're doing and analyzing a problem for clients, you need to read a lot. So it doesn't mean that you read a lot of code, but you read the business application and see the problem that the client is experiencing from their own face. Yeah. So in summary, yeah, so frame the business problem. Yeah. So previous known outcome from reliable different sources and industry experts. Figure out whether costs of failure does create repetition damage, then facilitate experimentation with automation. Yeah. Then decide where you need to scale. So not all the points there, all problems can be solvable using analytics. There's some problems that you just need Excel. There's some problems that you may just need to go and sit in someone's office and thrash out using some doodling or diagrams, and you're able to solve. There's some problems that you may just solve using Excel, so it doesn't need to go the full length of deployment or of the script of Python. So I hope this explains to you how problem identification is done. And if you miss out on this step, then the rest of the project can collapse because it means you're not solving the right problem using the right approach. So it's important that you get this right every time you're engaging in a data science project. Yeah. So any questions on the problem identification, problem solving? Any questions so far? Okay. So we'll proceed now to the next step, which is the business understanding. So what does it mean to understand a business problem? Yeah. So for instance, yeah, a credit card example, you want to make sure it's underwrites customers who could pay, or another one could be detecting fraudulent customers. So the intention can be to reduce risk and same time increase revenue. So that's where you play around with the KPIs. So you need to have a strong guidance in terms of understanding how departments work, what are the measures of performance for each department. So those of you with a business analyst background do this from time to time. So you look at risks, you analyze the potential risks on the various decisions that the business is making, and then you advise the business appropriately. Yeah, so we encourage you to continue looking at the business application side because it helps reduce on wrong decisions. And when it comes to feature engineering, if you're the one calibrating the model, that's where you'll be able to do the right job in terms of intervention. So I can give you an example. For example, you get a data scientist from the US to come here. And when they're looking at banking transactions, for example, they start looking at cents. You know, like our ATMs don't dispense cents. Yeah. In the US, you can still get cents because it's a pound dollars. So when you look at that, when you're building a model and doing some ADA, you can put some dots. Yeah. Maybe use a float integer, a float data set in the place of an integer data set. And that can bring a problem when you want to deploy in the real scenario. Yeah, so understanding the business context really matters. And that's where we encourage development of data scientists from within the company so that they can be able to give the right mix of solutions to the clients. Yeah, so these KPIs, I've talked about KPIs, so measures your performance against key objectives. So businesses use this to measure their objectives and overall health of their business. Yeah, so it's crucial to agree upon the right set of KPIs for each business and not fall into the trap of chasing vanity metrics and great or not meaningful. The other part is SLS, which is service level agreements. So this defines the level of service expected by a customer from a supplier, laying out the metrics by which that service is measured. So for instance, if you're creating a very complex pipeline and you have an SLA of 100 milliseconds you have to meet, process like 2,000 transactions per second, you have to make sure that you meet your SLA and KPI. Otherwise, the model won't be of any benefit to you. Yeah, so this is one of the areas that we use to keep our vendors accountable when they give us their systems to use. Yeah, so SLA is another source. So we talked about looking at the business objectives, looking at the KPIs, and now SLA is another way that you can be able to get a key measure. So the business objective must be simple and clear in business terms. It will mean increase my revenue by 5% and attract more customers and reduce the number of customers churning by 10%. Yeah, so remember about SMART objectives. So also these play also they play around in this era of predictions. So for example, it should be reducing the mean squared area of the model, yeah, from this to this. Yeah, we're talking about the p value. Yeah, so being able to create a p value of less than 0.3%, 0.3. Yeah. So I wanted us to do a short exercise, but as we summarize, just to understand what are the business objectives, understand the scalability needed, defining your success criteria, and measuring your KPIs, so an SLS, and identifying the key business variables the model needs to predict, then discuss the integration of the model in the business process. Yeah, so just in about 2 to 5 minutes, maybe we can look at those website links that I provided. And I want you to create a mix of KPIs that you think may be worthy to interrogate further when you're building a use case. And then I would like to have a volunteer or two just to take us through the process of creating a business understanding, an argument using the process that we just described. So I want you to use this. You can pick one KPI from the employee KPIs.predict for employees, or you can check from here and pick one KPI. So I'll give you some time to go through the KPIs, and then when you come back, just choose about 2 or 3 KPIs that you think may be mixed to solve an analytics problem. Yeah, so who is ready? Who is ready to try out their model? Remember, it's just constructing, so I don't expect any tangible numbers. Thomas, we can have you. And Phoebe. Yes, Thomas, you can proceed.
Maybe you can look at the customer lifetime value.
The customer lifetime value. Okay. So if you construct a business understanding of it, can you describe how you can be able to, and you can feel free to use your brand as an example.
Maybe you can look at this, how much, okay, the value, okay, the sales the customer is bringing to the company, monthly sales.
Yeah.
The items he is buying.
Okay.
What he is stocking in his shop, he's stocking competition products or just us, our products. What else? His credit terms. In terms of his debt days, credit limits.
Yeah. So thanks for that. And as you continue identifying those sources, you're able to identify the sources of data?
Yes.
Yeah, so for example, just give us some sources of the data where you'll be able to find it.
For the sales?
Yeah.
We have on the customer cards, customer list. We have that is where we can get his credit terms.
Okay.
And data.
And the POS. The point of sale, ERPs. Thomas?
Yes.
So I'm just mentioning the possible sources of data, yeah?
Yeah.
The ERPs, the POS, and the such, yeah. Then next, Phoebe, you can share yours. Thank you, Thomas. So Phoebe, maybe you can share yours. We just an appreciation of what of the KPIs, some of the KPIs that you may want to measure for the business.
You can hear me?
Yes, very well. We can hear you very well.
Okay. For me, it would be probably look at the net profit for the predicting for the coming year.
Okay.
The net income.
Net income, yeah.
And the revenue growth.
The revenue growth, okay. Yeah, so you want to, yours is mostly an executive problem. You're looking at the balance sheet.
Yes.
All right. Yeah, it's a very key area for the banks. And for example, you may want to look at what's the effect of the base lending rate, yeah?
Yeah.
Yeah, so for example, the CBK reduces the base lending rate. What's the impact of that on the balance sheet?
True.
Yeah, yeah, yeah. So thanks for sharing that. So that's how you construct a business problem, and maybe just to encourage you to keep looking at the business side of things and bringing on board some of those openings and insights into the analytics side. Yeah, so we're gonna move to the next stage. So, which is now data acquisition. And this is where now it starts looking a bit familiar, because I know most data scientists struggle in those first two stages. Yeah, getting to understand the business understanding and framing the problem are very, very problematic to data scientists. But there's nothing as painful as embarking on a journey without knowing what destination you're headed towards. Yeah, so from here on, it's going to be sail in the park, because I think once you identify the problem, and then you're able to utilize the tools that we've shared, such as the KPIs, to be able to frame a business understanding of the problem, the rest becomes straightforward. So data acquisition can be framed as a ETL. Yeah, so you'll be hearing a lot of this term ETL, extraction, transformation, and loading pipeline. Yeah, but essentially, it means collecting of the data and then putting it in a centralized way. So maybe it's in a database, yeah, somewhere. Yeah. So these are the three steps that this involves. For example, it's extracting. So you may be extracting data from a single or multiple data sources. So the example that Thomas gave, you could see a financial source. Yeah. You could see a source from the market. Yeah. And then also there was an example of how you can be able to get information of customer from the call center. Yeah, when you talk about customer lifetime value, you look at the 360 entities of a customer and what are the touch points of a business to the customer and how do you interact with that customer across the different dimensions. So it's important that we put that in mind. On data sources, again, we have external and internal data sources. We have transformation, which is data as per business logic. Yeah, which means data can be there, but what is the business interpretation of that data? Yeah. So, for example, when you look at peaks in transactions, yeah. So, what is the interpretation of that? What are you looking at? So, the two things we look at: data and metadata. So, what story is that data telling you? Okay. So, transformation of that data is very important. You can play around with the two features of key data and then extracting information from that data, which is inferences. The other part is loading. Yeah, so how do you previously transform data into the targeted data source or data warehouse? Yeah, so this will be able to ensure that it's stored in the right framework. Remember, we have structured and unstructured data. So if you're dealing with text, images, and videos, you use now the Hadoop frameworks for loading. If you're talking about semi-structured data, you'll be talking about the MongoDB framework, which can be used for storing. And if it's purely structured data, then you have your SQL format type of databases that you can use for warehousing. Yeah. And then, of course, I want to share with you some of these data sources because I know we have not looked in that before, and I might miss out on some idea here. So just allow me to open a new screen. Share screen. So we have this. Yeah, so when you look at data, you look at this sort of a framework that guides structured and unstructured. So you have human generated data, and then you have machine generated data. So data coming from internally, from the company itself, and then external data. So data coming from, for example, open source platforms such as census data and whatnot. So this is how you can define your data: structured and unstructured, internal and external. Yeah. Also of importance will be this. So what are the types of data that you're able to lay your hands on? So from public versus private, these are both external, but one is internal for private, which means you could be having your own private data, but then you also have private entities that own their data outside there. So for example, you may go to AC Nielsen to buy data from them. The data is private to them, yeah, but you can buy the data from them. Yeah. So we also have this other part, which is the transactional versus aggregate level data. So this just gives you an idea of your data source. So how do you build up, for example, transactional levels, 3 months, 6 months, year to date, month on month, or you're looking at real-time data from an app, or transactions from a credit card, which are in real time. Yeah, so they also, another classification of a source of data will be first party, second party, and third party data. So for example, first party data is the data that you have yourself. Second party data is the data that you're holding in trust, for example, of your customers or suppliers. And third party data is data which is held by your vendors, for example, the SAPs, the Sage, or the Oracle systems, yeah, which are holding your data in trust. And number 4, we have inferred versus declared. So we have inferred data. So inferred data is data that you can be able to derive meaning by looking at the data pattern. So for example, when you look at the distribution of a product, you can be able to tell that on Fridays, people purchase more than on Monday because there's a more relaxation, or there's a pre-purchase decision. Yeah, the discussion we were having with Thomas at the beginning when we were talking about the battery, they're experiencing huge orders of battery orders. It means that the inference is done is that during COVID, most cars are at home, then there are no imports coming in, so they're taking advantage of that. So this is how you look at data. You can also look at data in terms of time series. From time series or historical data. Yeah, so in the banking, they say there's a T-1, T-10. So T means today minus 1 day, or today minus 2 days. So how fresh is the data coming in? Yeah, so this is another where you can be able to describe your data source. There's also customer data, yeah, which will be described, data coming in from different entities. Then there's product usage data. So metadata coming from third parties such as AC Nielsen, yeah, for consumer brand tracking. You may have IoT devices installed in devices that can be able to tell the usage of the different products, yeah, and telemetry, which is used to stream that data in real time. For the case of telecommunication networks, they use a lot of that to tell the network optimization. Then of course, shopping data, yeah, from supermarkets, loyalty cards. There's conversation data, social media data. These ones go together. So using natural language processing, are you able to mine data from Facebook, Twitter, and about the trends of your products? Then public data, census data, and API data. Yeah, so API data is another important source of data. So for example, this helps get secured information point to point. Yeah, so API stands for Application Programming Interface. So for example, we have the Credit Reference Bureau. You may want to buy a score from a customer, and that score can be used to predict, yeah, whether that customer has another default from another financial institution. So we use API data to fetch and correlate with your data. So all these are solutions available for you. Census data, again, very important to be able to triangulate and correlate the value of, for example, segmentation of your markets, market penetration, being able to track demographic trends across different markets. And for example, for a bank, you want to do product profiling. So you may want to know if you've got a female SKU brand, or if you have a young target, a product targeting a young population, how do you factor that segmentation with the different markets? So I just deviated here to show you some of the sources of data. It appears to be one slide on the other side, but it's really, really a big area that you need to pay particular attention to. So as a lab, we have some open data sets that are available for you to be able to cross-triangulate. You can be able to check one of our platforms. If I may just show you right now, and give you time to go and play around with it. So let me just share this. Yeah, so this is a geolocation intelligence system. This also shows you another type of data that you can use when you make your analysis. So it's an engine that has different data sets to be correlated and triangulated, like you can see here on the right. We have data, for example, for Uber. Let me move to Nairobi. You have data from Uber, which you can use to look at the different traffic times. So when you activate that, you can see the places which in red mean they have high traffic areas. You can correlate it with for example, Nairobi sub-locations. You can see the population in each of these sub-locations. So which means this is data that you can use to triangulate. So this is a source of external data that you can use in building models and recommendation engines. So when your creativity actually starts at that point. So once understanding a business problem, then you start moving on to appreciate the different range of data that you can be able to play around with to have a full impact on the business value that you want to create. So at this level, remember, it's about applications and creativity. So I'd like to encourage you to keep looking out for the key nuances of a problem that you're trying to solve and the possible data sets that you will need, and not just to rely on one source of data. Yeah. So we can move on back to the original presentation.
Question, Tim.
Yes, please.
For loading, why would you recommend that we load the data? When you say loading, does it mean that we load it into, say, for example, Python as CSVs, and or should we load it into databases? Or should we do it as flat files, as blobs?
Yeah. So yeah. Thanks for loading. It's depending on the nature of the data, but because this is going to be a live production environment, you'll find that you already have databases existing. So some of this data may be so huge that it cannot even fit in your machine. So it's recommended that you load into a database. So what's going to determine is the type of data that you're talking about. So for example, if it's image data and then it requires huge storage and a processing capability, then you have no choice but to consider cloud storage. So that's where you have the interfaces to AWS or Oracle Cloud or Google Storage. Yeah. So loading here varies depending on the nature of data that you're dealing with. Yeah, but the option will be depending on when you're building on the development stage, you can store it simulated data a little on your Python notebook, but after that now you move it to the live production environment, the deployment stage. Yeah. So I hope that answers you, Moses.
Yes, it does. And what about the transformation? We use Python to do it? Or?
Yes, transformation, we use Python. So basically data cleaning is a very manual process. So what we covered during NumPy and Pandas, that's basically what we'll be doing. So rearranging the rows, deleting some rows. Yeah, it's basically that. Okay. Sorry. All right. Good, so now we are halfway through the data science process. So we finished the ETL. Yeah, what do you do after the ETL? So for example, you try to input missing values, like what Moses was asking. So continuous values, yeah, which we call them null values, mean, mode, median, depending on the need, categorical values. Yeah, so these were what we were exploring during the NumPy and the pandas. So in summary, data acquisition, which is the ETL. So you gather knowledge about the data origin. So I've shown you some of the origins of the data. Do some extraction, transformation, and loading. Identifying the apply the data quality and cleaning rules. So identifying which data will you need. And then check if the labels are available for observation or not. And then produce a high quality data set with the relationships to the target variable. Yeah. So the next stage after this will be EDA, yeah, which is exploratory data analysis. Yeah, so the two things that are happen here, which is how are the different variables related to one another and what's their distribution look alike? What is the correlation between the variables? Looking for evidence on how to well connect the data to the target variable. Yeah, so this is where you use now your matplot, Seaborn, basic, starting from the very basics using charts. Yeah, but basically this is a statistical use. So for example, we have 3 areas of statistics that we explore. So the first one is called descriptive statistics. So which just describes, yeah, the data based on its properties. Yeah, so the 4 major types of descriptive statistics: measures of frequency, measure of central tendency, measures of dispersion, variation, and then measures of position. Yeah, so you come across terms such as the kurtosis, centers of spread. Yeah, where is the curve leaning towards, to the left, to the right, and that becomes a key where you can be able to look at how the data is spread. So you use charts to do that. Then number 2, you can use inferential statistics to validate the distribution across data sets, and then model outputs. So Dennis, are you there? Dennis Kevogo.
Yes, most certainly I'm here. Thank you.
You have that Python notebook for the descriptive statistics somewhere so that you can share the screen after this to just show them.
Okay. Let me try and trace it because this is a different machine, but let me try and trace it.
Okay. Just alert me when you do, then you can get the screen.
Sure.
Yeah. Yeah, so we use inferential statistics to validate distribution across data sets and model outputs, and the most used methods are estimation of parameters, testing of statistical hypotheses. Yeah, so this one's like we use it correlation coefficients to test if this happens, then does causation mean correlation? And then thirdly, we adopt to univariate or multivariate analysis to identify correlation and trends between dependent and independent features. Yeah, so plotting 2 variables, see how they behave against each other. Yeah, so you can be seeing X and Y. One means inverted, is it an inverted or linear correlation? So this is where now you use the charts to describe that. Yeah, so under this EDA, it's a key way. Yeah, so for example, you can see how these ones have been visualized. Yeah, spread on one. Yeah, one is flat, another one, you can see the clusters. Are they in one place? Yeah. So very key areas of data exploration that can help you look at a distribution of data across different spectrums. Yeah, so these are some of the charts that can be used. And again, I've given you a link there. I posted it. You can try out a platform that we have for charts, which you can use to experiment how the different visualization. So for the new students, we have a catalog, the data visualization catalog, which has got about over 80 types of charts and where they're used. So Alice, are you on call? So I'll just note that down, then we can email it. So we'll email it as part of the notes, the data visualization catalog that can be used to guide you when making a decision which chart to use for EDA. So data visualizations play a critical role in this. deployments. We look at, for example, being able to identify plotting simple patterns on a graph. So this makes the patterns and trends much easier. We also have information pulled from statistics. Then we get the insights from the data without visualizing. So these are key areas that we can actually embed on the ED, and some actually analytic problems are solved at this stage because you can make your decision from looking at a chart. So you don't need to move on to the next stage if you can be able to solve some problems from here. But then, yeah, we can build up on the next step. So in summary, for the EDA stage, so we use inferential statistics to validate distribution across data sets and then model outputs. Yeah, we use descriptive and inferential statistics to understand the data, univariate and multivariate analysis to identify trends and correlation, and then use visualization techniques to better gain insights along statistics. So if you're looking to pursue some statistics studies, so these are the key areas that I recommend you just go and study. Yeah, so from last week I showed you the different branches of statistics that are critical in data science, and now you can see where they play. Yeah, so these are the areas that we are very keen in data science from the statistics branch. Yeah, so we have further reading materials on this, so just chat to any of us, me or Dennis, and then we'll be able to share with you some of the key learnings and even Python notebooks on the statistics side that are relevant in building models. So Dennis, have you discovered anything?
I think since when I switched to the machine, I can't really trace it. But
okay.
Then I'll just check through my emails and then share.
No problem. Yeah, so I'm finishing in about 10 minutes, so you should be getting ready on your side with the intro. Eh?
Okay, I'm good.
All right. So on the next stage, we are looking at feature engineering. So what is feature engineering? So this is the process of using domain knowledge to extract features from raw data via data mining techniques. So I like to underline the word domain knowledge. This is where the whole difference comes. So if you're a data scientist in the banking sector, when you go to the telco, you will struggle because you don't understand the domain of telco. So the process 1 to 3 will help you gain some grounding in the telco or the new area that you want to explore the data. And that's why that foundation of problem solving helps you to build a strong foundation for you to solve these problems. Yeah, because there's no excuse. You cannot start doing feature engineering without knowing what you're testing. Yeah, so these features can be used to strengthen the performance of machine learning models. So feature engineering can be considered as applied machine learning. Yeah, so we say that machine learning consists of only 20 to 30% of an entire data life cycle. So you can see where does the other one, what we've done from 1 to 4 already consists of the other 70%. So the most meaningful techniques of feature engineering are used to transform data into from where a model can better understand. So we've got what we call the data transformation techniques. Yeah, so these are key techniques that you need to learn. So we'll be teaching you about log transform, square root transformation, categorical encoding, power functions, and scaling. Yeah, so these ones are ones which are used to transform data from one configuration to the next. Then when you're dealing with skewed data, we also have bias mitigation, we have binning, outlier detection. Yeah, so the latter identifies data points or observations that deviate from the dataset's normal behavior. Yeah, so the outliers data can indicate critical incidents such as technical glitch and potential hazards. Therefore, these need to be treated according to, otherwise to mislead our final models. For example, in the area of data, in the area of cancer detection, yeah, so this is where it comes in. So you're able to look at the DNA encoding of the genes, and there's some genes which appear to be outside the normal spread. And those are the genes that are zeroed in to investigate as the causes, the genes that cause cancer. Yeah, so these techniques are very critical, and the same techniques which are used, for example, outliers. Yeah, so guys who are able to default on loan payments, yet they have a very good history elsewhere. Yeah, so we are seeing a lot of this emerging outlier detection, especially this post-COVID, where we are experiencing a new normal, where we are not able to. We're working what you call the unknown unknowns. So things that we didn't know before. So we're just discovering and experimenting with. So after transforming the data to the right format and dealing with the potential data hazard, so most of the time, especially with a high dimensional data set, we have got many features. Yeah. So again, we look at the data analysis or EDA. Yeah, the term that we use here is called feature selection. Yeah. So feature selection means you're selecting a feature with the with the highest importance that you're able to use to rank. So we use again statistics here. There's what we call filter-based method. So this is correlation or chi-square or ANOVA. Then we have got rubber-based method, yeah, which is a recursive feature elimination, forward-backward selection. Then we've got embedded method. So we use algorithms that have inbuilt features to select methods, lasso, L1, and bridge, L2 regression. So this is pure statistics, and we'll be giving you guidance on how each of these is applied at that level. And this is where we'll be spending more time to look and study. So in summary, in feature engineering, this is where the summary looks like. So we've got digital transformation, log transformation, scaling, encoding, grouping operations, and then of course showing you how to deal with skewed data, bias, and mitigation. Then application, selection of the features, most useful for the problem. Yeah, so this gives you an indication of what lies ahead. So I've taken you through the journey. There's one more step which is remaining that I'd like not to touch now because it's about deployment, model training and deployment. So this one, I wanted to touch it midway. After we've done the midway review, you can be able to expand on that. So what I'll do, I'll be sharing these notes and other extra links. And I hope that this is going to form the basis of this course. So whatever readings, private readings or otherwise you're going to read, please try to confine yourself to what is within here so that you don't confuse yourself. There's a lot of content that we have prepared for you along this journey so that you don't end up getting an overload of information that may not be relevant to what we have curated. Yeah, so any questions so far?
Kindly share the PowerPoint.
Yes, I'll share the PowerPoint. And then also there's a quiz that's associated with the PowerPoint. So I will share both and extra reading materials and links. And please, I'd like to encourage you to just read lightly. Don't go so deep into the statistics side of things. Yeah, we'll prepare for you some simple notebooks to be able to grasp some of the concepts in statistics. Yeah. So Dennis, are you ready?
Yes, I am.
Let me make you the host. Then you can take over from there, but you can continue.
Okay, thank you.
All right. Okay.
Okay, thank you. Okay, fine. So good morning once again. I promise you that this is going to be a very interactive session, and I'd once in a while ask you a number of questions. So I'd like to do a very brief introduction to artificial neural networks, which is in essence neural networks. But then just to joggle your mind, what comes to your mind when you hear about neural networks? Anyone?
Think about the brain.
Exactly. Thank you so much. Oh, so that's amazing. So you think about the brain. So in essence, artificial neural networks or neural networks are simply algorithms that are going to mimic the human brain. When you talk about neurons, when you talk about different layers within the brain and how the signals are sent from one end to another, and the different layers that are there. This is the input layer, this is the hidden layer, and then this is the output layer. It exactly mimics the human brain. And something else that you can think about is, you can now think about artificial intelligence. You can think about deep learning, because deep learning is now the complex form of machine learning, whereby we talk about layers. And that's where we introduce now neural networks. Okay. So fine. It's been something that has been in development from ages, that is in 1943, where neurologists and psychiatrists have been trying actually to use logical calculus of ideas imminent in nervous activity, trying to understand how then can we use mathematical models and formulas to mimic the human brain. And the development has not, and rather did not just start even in 1943. I believe most of you know the story of Alan Turing with the Enigma machine. If you don't know, maybe you could find time and look at that. That is an aspect of artificial intelligence, and that was the start of the journey of even understanding neural networks and deploying the same. So the earliest of the developments, we would say, was in 1943 by a neurologist. And you can see this is the structure of the brain, rather how it looks like. We have the dendrites, which receive the signals from other neurons. When, let's say, you're pinched, that neuron sends a neuron to the brain, because you have that nerve, rather, sends a signal to the brain, and they're received by the dendrites. And then through this, you would now, in essence, call the input layer in neural networks. And then this is a hidden layer, and then this is the output layer. So once they receive the signal, it will be processed within the axon right here, which in neural networks I'll also be able to take you through within the hidden layer, where we have the activation function, which will be able to determine then if this neuron should be passed or not, if that signal should be passed or not. So this is the simple structure of how a neural network looks like. And like I've said, it will always mimic the human brain, because we have the input layer, because it will receive signals. And then we have the hidden layer, which we actually have what we call feature extraction, as Timothy has just talked about. Now, in this case, we have different algorithms, which I'll be able to take you through in the course of our journey in this course. And then we have the output layer, which will now give the feedback from the hidden layer on to different expected results. And I'll be able to demonstrate just a simple demo of how a neural network works, so that you can be able to conceptualize the same. So, like I've already mentioned, we have the AI winter. This is when now the face of artificial intelligence was taking shape. After now the aspect of, or rather when Alan Turing now discovered, or rather was able to break the enigma. He was able to break the enigma. Let me just give you the story. Maybe you might not find time. So it was during the Second World War, and we had the Allies, and we had the other side, that is Germany and Austria-Hungary, and then we had now the current superpowers, or rather the veto powers. We have Russia, USA, and so on. So on the side of Alan Turing, who was an Englishman, he was able to know when Hitler was about to send a bomb, or was about to send, let me just call it a bomb or something, to the UK. So he was able to predict, and he was able to know that this is when this was going to happen. And he was able to, using his own knowledge in mathematics, he was able to tell what was the password of the Enigma machine. And from there, now Hitler became so predictable, and that was his downfall. So yeah, so if a neutron is a single layer, or if you have a single neural network, that is what we call a perceptron. And then if we have multiple, it's called a multi-layer perceptron. So that is, you will likely interact so much with perceptron. So perceptrons are normally linear, whereas multilinear perceptrons are nonlinear. And that's where now we introduce the activation function, which ensures that there is nonlinearity. Don't worry about the terminologies you're going to familiarize with in the course of our journey. So as you can see here, the dendrites right here, they receive the nerve impulse. And then the soma, which should be along the axon, is the central part of the neuron, which is now our hidden layer. You should be able to work, it is the computational unit. That is where the activation function is in the common now neural networks. And then the axon will drive electric signal from the soma through the synaptic zones to the other neurons. And basically, that is how the normal human brain works. So again, before I finish, in this particular problem, you must be familiar with the line of best fit that is now in linear regression. This is what a perceptron can perform, only a linear function. But then when you come to a multilinear, where we have regression and even classification and more, that is where a typical neural network would come in. So the algorithm here is the neural network, which mimics the human brain. That's why it's called even a neural network, from the word neuron. And then the problem, in essence, let's say if it's a object detection problem, which I will also be able to demystify for you. Then from there, it's now automated through artificial intelligence. So any questions so far? Just in case I make sure I'm not moving too fast. Okay, good. So I assume it must be very interesting, if not. So some of the developments that have taken place since 2012, now wouldn't really take it through the journey from 1969 to date. But some of the developments that we can see today, up to today we are talking of object detection and so on, were rather visual processing and understanding, that is images and videos. Face detection, I've just seen Tim has posted on Facebook of how face detection can be able to tell the difference between a portrait and the real image of Timothy himself. So that is an aspect of actually neural networks. And then we have language processing and understanding. Today, people talk about Facebook, or rather Google translation. That is an aspect of language processing, which is NLP, natural language processing, which is now, you will find it under what we call sequence data in RNN. And then we have time series processing, and of course, defaults checking. I'll also give you a very interesting use case of neural networks. That is by Delta, which in essence is the largest airline in the US. So Delta are trying to apply an aspect of artificial intelligence, of course, using neural networks, whereby we have, in the airports, we have a large common screen, but then 100 users, let's say myself, I'm headed to Dubai from JF Kennedy, and maybe Moses is also headed to, let's say, Japan. So you just see your travel information. We will all look at that screen, but at the same time, I will see my unique travel history of my travel documents, my travel process and everything. And then Tim will also see a unique, like what concerns him. That is an aspect of also neural networks in application. So a good question that we'd ask ourselves, because today we are in the advent of artificial intelligence.
Dennis,
yes.
Question. You mentioned the use of the AI in the case of Delta. I have a question. In terms of using AI and machine learning, where has it successfully reduced instances of cybercrime?
Why hasn't it?
Where in instances has it reduced the instances of cybercrime? So for example, where have we been able to successfully say we have used AI and machine learning to reduce the cybercrime instances, or to deter cyber attacks?
Okay, fine. I think the quickest one that I would think of right now would be, even as you have alerts, we have manual alerts and we have artificial intelligence alerts, that is in fraud detection, that is machine learning as well. And then we have a manual response and an artificial intelligence response, whereby you maybe just get a response from your bank, for example, that this is indeed a fraud case. So largely, the automation of that process using artificial intelligence has taken a key step in the market. So it's largely been used in reducing cybersecurity in terms of speed. And of course, when you train a machine more than often, then you should learn from its history and even beat the human. Because you can think of manually, maybe using a watchman to tell this is the owner of this particular card or something. So even in cybersecurity, it has largely been at use. Or maybe if Tim has any other use case, he might also be of input.
Yeah. So Moses, maybe just to add, the login credentials for I'm not a robot. That auto login when you're logging into your emails.
Yes.
Yeah, that's machine learning. So it enables the system to block itself. Yeah,
okay, but I'm looking like for real life situations, maybe where we can say, you see there we have certainty, we can say we have used machine learning, for example, to check the churn rates and predict churn in the future. Do you have instances or examples of where we can say maybe Bank X used machine learning and AI to reduce fraud, right? Or maybe a certain institution used or is using, or by the use of AI and machine learning, they have seen a reduction in cyber crime by X%. Do you have such cases?
Yeah. In banking, maybe Dennis, I can just ask. In banking, there's a model called the Benford's law, which is used in processing of large amounts of transactions. So that problem can only be solved using machine learning, detecting fraud, and also using unstructured data, some things like image recognition, voice recognition, to be able to detect outliers. The other day you saw Obama's image being transformed using machine learning to appear like someone else. We also have platforms that do gait recognition. You know, the way you walk is also unique. So those models which I used to develop the gait, and they're actually even used in the developing tackling cyber crimes. So there's a project being done by the US Army. I'll share the link on the group. No, not the US Army, the US presidency. So they released a report last week on how they're using machine learning to solve the next wave of cyber crimes. So it's a bit detailed, and it shows some of the scientific work that is underway. So a lot of this work is still underway. So very few use cases are out there available outside the banking and high volume transaction platforms.
Just one other example, Moses. MasterCard has implemented AI in their fraud detection. So what they're doing is they're monitoring customer spend patterns, trends over a period of time, and versus they're monitoring it real time. So the moment there is any suspicious transaction, the customer is alerted randomly or impromptu that is this actual transaction because it looks outside of the norm. And then based on that, they're able to stop fraud from happening.
Who is that? Sorry, who is that?
MasterCard.
MasterCard. Ah, okay.
They've already got it in place.
Okay.
Dennis.
Okay.
Can we also say the use of voice as a PIN code? Can you give that as an example?
Exactly, that it is. It's an application of artificial intelligence as well. Okay, fine. Any other question? I think they have given more than enough use cases, and that's amazing. But I believe that's why Tim has said you need to read quite a lot. You will really interact with a lot that is happening so far in the world. So then how far are we from the brain? What is the distinction? So here is a section for the brain, and then here is a section for the existing efficient neural networks. So you can see that the brain currently uses 25 watts, which is about 1.7 liters. And then for the neural networks, it uses 250 watts. So technically, now that it's even artificial, it's already ahead of the human brain. But the key distinction that you may need to know is that, which is a development, is called affective computing, is the aspect of artificial intelligence being integrated into emotions and emotional intelligence. That is an aspect that is unique to the human intuition as opposed to the machine. It might take a while before we achieve that. And that is also quite a question out here among the data scientists and artificial intelligence experts, whether there will be emotions involved in terms of even in robotics. If a robot will be able to, it can be able to read emotions currently actually in terms of your facial behavior, but then it cannot be able to react emotionally using intuition. That is the key thing that's why the aspect of even general artificial intelligence comes in. So you can see that the training time that is used by the neural networks currently would be around a day for even 1 million images. And then the training time from a human level, vision, even language, movement, emotions, behavior would even take up to 3 years, to take you up to 3 years to be a very good, let's say, actor or something, even in emotions. Yeah, those are just some of the quite practical examples. So I'd say from my side as an expert that neural networks and actually the advancement in artificial intelligence are up with speed. And likely the only aspect that we would miss, maybe not in our lifetime, or rather in our lifetime, is we will not be able to see the aspect of affective computing or emotions achieving at the desired level as we would think of. Okay, so we have types of neural networks.
I have a question.
Sure.
I can see there you've indicated that it's 250 watts GPU. Why is it that we use GPUs and not CPUs for machine learning?
For machine learning, I think that is something we are going to interact with in TensorFlow when I introduce you to Google Colab and TensorFlow, and it's an aspect of actually speed and the processor speed, and I'd be able to as well when we get there respond adequately to the same. Okay.
Okay. And maybe just to add, is a GPU is graphical processing unit. So machine learning computing requires a heavy processing power for it to be able to compute. I can give you an example. Just when you do 1 + 1, you can do it on a calculator. When you do, for example, that's 8.6 to the power of 9. Yeah, that cannot be done on a calculator. So the complexity continues to increase. Yeah, so the computation, for example, there's another documentary I want you to go and watch called AlphaGo, which actually is another way to understand these neural networks, a project by Google, which they were playing a game of Go. Yeah, so GPUs are for heavy computing and require a lot of infrastructure. So a platform such as Python has got some embedded GPUs. However, it's a bit limited. Of course, it makes it better than Excel to analyze some models. So the complexity of analysis changes. So mean, standard deviation, those are basic computations. But when you move to more complex computations, such as linear regression, when you move into complex equations, such as the KNN algorithms, if you try to run them on Excel, your machine will hang for a full day. So that's why we use Python. But then again, Python has got also its limitations. When you start analyzing unstructured data, such as voice, images, videos, text, that's why you start using the GPUs, which is a graphic processing unit. Yeah, so I hope that explains, Ernest.
Yeah.
So GPUs are quite expensive. For the purpose of this class, we will be using Google Colab. The other alternative will be for you to set up a virtual machine on cloud. Yeah, so there are different options, but fortunately for us, Google has got a platform which we'll be able to use to run active shells. And yeah, so there'll be less of Python notebook, there'll be more of the Google Colab.
And also another question.
Yeah.
Let's say your computer comes with a dedicated GPU. Are you able to set it up locally, or it's impossible? It's limited.
If it comes, yeah. There are some machines, especially the ones used by gamers, come with the GPUs that can be expanded. Yeah, but you need to be ready to pay huge electricity bills. Yeah.
Okay. Thank you so much. I love such questions. Yeah, so it was,
maybe, Dennis, just to add on what Tim said. So for example, if you want to buy a cloud service, say for example Oracle, and part of what you choose is whether you want to use CPUs or you want to use GPUs. And normally before you purchase, they will tell you the prices. So then you can choose the number of GPUs you want based on, say, for example, the sizing that you need. So you probably need to know what size you need so that you can be able to know how much GPU you need so that it can be cost effective for you. Otherwise, it may be too expensive if you get so many GPUs, especially if you're not using all of them.
Okay, thank you. I think Moses, I need to talk you because I'm doing an exam with the autonomous database in 2019. Okay.
The foundation course or which one?
Yes, the foundation course.
Ah, okay. Yeah, you can talk to me. I did it this year, so I could see what I could do to help. Yeah.
Sure. Thank you. Okay, so thank you so much. So as a matter of calculation, as Tim has said, it's just an aspect of speed. And then there are three different types of neural networks. There's one called generative adversarial neural networks, but we would not largely look at that, but it's majorly used for image processing and video processing. But the key ones that we look at is recurrent neural network and convolutional neural network. So recurrent neural network actually deals with sequence data. And the key thing when RNN runs through your mind, you should think of text mining. It's usually used in text analytics. And then when CNN runs through your mind, you should think of computer vision, think of face detection, object detection, and video imaging. And so some of the machine learning problems under recurrent neural networks, we have document classification, identifying a topic in a particular article, because it can be quite wordy. And then we have sequence-to-sequence learning, that is in translation machine. Today, people do transcription, people do use Google translation largely from different languages. That is where RNN comes in handy. And then we have sentiment analysis. I believe once in a while you've heard of sentiment analysis, which we will also maybe look at it as a use case. And then we have time series forecasting, which Tim quite mentioned it. And then we have CNN on this other side, where we look at the aspect of computer vision, like OpenCV. Largely, this is what is taking place in the world today in terms of technological advancement in artificial intelligence. And then we have face recognition, scene labeling. These can really largely help in NIS, even in the US, you can talk of SWAT. They would use computer vision largely in this. And then we have image classification, action recognition, and then human pose estimation and document analysis. So most of these use cases would sound so interesting, but if we find time and look at them practically, especially the back-end side of it, then you'd see the need of having them even in mind. So for CNN, just like Timothy has mentioned, we have something called feature extraction. So, but in CNN, using autoencoders, we do use convolutions, pooling, and budding. This simply is a process of smoothing and filtering different images so that you come out with the fineness that you'd want to, especially in image classification. So for today, don't really mind the jargons if you hear any, but I'll take you through as we continue with our journey in this course. So this is the latest application that was actually published today. That is, not today, that is 3 days ago on 3 or 4 days ago. UFO, that is unidentified flying objects, is an application, a key application of CNN in object detection. So UFO hunters in the UK were able to see such an image that was in the afternoon of 7th July. And then this would tell them that likely this is an alien ship, rather alien space shift, but now miles and miles away from the world, or rather from the Earth. So this somehow would try to prove the aspect of whether aliens do exist or they do not. These are some of the things that if you try to think so hard about, you might turn religious. Okay, thank you. So that closed down on the introduction. I'll just take you through a brief demo of how a neural network works. And then from there, you'll have a clear picture of how it looks like. So this is not my development. You can see my screen, Tim. Maybe you can see my new share, right?
Yes.
Okay, thank you. Yeah, so this is a typical neural network playground. Just like I've said, it's not my development, but it's something that is available. It's open source. So I talked of the input layer, the hidden layer, and the output layer. So in the structure,
you can't see.
You can't see?
We can't see.
Yeah, I can see. We are still on the UFO
I'm
object
seeing the
detection.
PowerPoint.
Okay, new share. I think now you can be able to see. Just a minute. So are we now together? Can you see?
Yes.
Good.
Yes.
Okay, thank you so much. So like I was saying, this is not my development. It is something that is open source. You can also find time and play around with it. So you have the input layer, you have the hidden layer, and the output layer. Remember the dendrites, the middle region, the axion, and then the sigma, and the last region, the, forgive me if I don't get the medicinal, rather the biological terms so accurately, but then that's how it imitates the human brain, rather the brain. So the epoch, we have the epochs. This is simply a measure of the number of times you're going to train your algorithm, your neural network algorithm. So the learning rate you would choose. So if your model does not perform well, you'd keep changing your learning rate, either increase or even reduce. It really varies, especially depending on the batch size, which is the amount of data set that you are feeding your machine in batches. And then we have the activation layer or the activation function. It can be tangent, hyperbolic tangent, it can be sigmoid, or it can be linear. I'll also be able to demystify that in our next class, probably. So this activation function is used to introduce the aspect of non-linearity. So it's the one that will determine whether that particular neuron that has been passed to that particular signal should then proceed from the input layer through to the hidden layer through to the output layer if the number of weights are not, or it's more than 0. And then we have regularization, or better known as penalization. It can be L1 or L2. So for regularization, this one is used to improve our model performance by reducing the loss function. And one key technique that is used and rather can be used in regularization would be autoencoders or autoencoding, or even gradient descent or stochastic gradient descent. And then you can choose your regularization rate. And then regression now is you choose which algorithm or which machine learning model you want to use. Is it regression or is it classification? Who can tell me the difference between classification and regression? I know you've really interacted a lot with this. Or rather, are they supervised or unsupervised machine learning algorithms? Okay, so classification, the difference between classification and regression is that for classification, it's binary. It's just 0 or 1. That's why you use it for spam detection, email spam detection. It's either even in fraud detection more commonly. And that's where even the classification matrix comes in. Is it a false positive? Is it a false negative? Is it a false negative, or a false positive, or a true positive, or a true negative? And then we have regression. And then both of them actually in essence are supervised machine learning, because you can be able to label your training data set. And of course, you already know what you expect, that is in terms of your target or predicted variable. And then regression, that's where even the linear regression, general linear model comes in, whereby you introduce a number of regressors, a number of factors in order to train your machine. Quite a good example Tim has mentioned in the HR detection, whereby you introduce a number of factors. So I'll just proceed to do then the demo, because I've chosen the learning rate for 0.0001. The activation function, I've chosen sigmoid. And then regularization, I've chosen L1, and then the rate 0.3. And then you can be able to increase the number of layers or reduce the number of layers, sorry. So once it trains, you're supposed to look at the output here in terms of the loss. The aim of this practice, or the aim of machine learning and even neural networks, is to reduce the loss, to minimize the loss. To minimize the loss, meaning when you minimize the loss by reducing the cost function or the loss function, then you are increasing the model performance. So you can increase the number of layers, or even reduce the number of layers. So on this side, let's maybe try. We can see that the training and the test loss is, let's wait for Reason to finish so that we try and change. Maybe we use L2 for regularization. So noise is simply randomness, or rather any information that is irrelevant. But then you can introduce noise to improve your model performance, because if your model, let's say it's overfitting, meaning it's pretending or acting like it's a perfect model by giving you a high accuracy in terms of the training and the test model, you introduce noise, that is the external noise, and then the noise will be able to reduce overfitting. So in a typical machine learning model, you have also to choose your training data set and your testing data set. You choose the ratio. Is it 60 to 50? Is it 80 to 70? But traditionally, one thing you should know that you need to test. You need to use more in testing than in training, or rather in training, in testing than in training, so that it trains the machine properly. And then we have the batch size. You can choose it to be, you can increase or reduce. Just look at the way your model performs. So you can see here, the test loss has gone lower from what it was before. I don't know if it's lower or higher, but the test loss is currently at 0.17. So let's try reduce the batch size and see. So when you reduce the batch size, it should also likely spend less time. So you can see our training and testing loss has significantly reduced because I've reduced the batch size. So lastly, let's try a different regularization technique. You can see it has gone down. So actually, it's a matter of trial and error, even in artificial intelligence. Once you have the facts behind you, then the next thing would be try changing the learning rate, try increasing the learning rate or reducing, change the activation function, change the regularization or penalization, change again the regularization rate, look at the kind of model you have. That's how you will achieve a perfect, or not a perfect model. You can never have a perfect model, a good model. So I've actually, I'm winding up on this. I've changed the regularization. Maybe let me also increase the learning rate. So when in the near future, when you participate in hackathons, these are something you're like, some demos that you're likely to encounter, whereby you've just been given the model, but you need to build it. And of course, you have the datasets as well. But then as you vary the different hyperparameters, these are the hyperparameters: the epoch, the learning rate, the activation, regulation, regression rate, and the activation function. So you can see our test loss is not really reducing, but I think it should be slightly lower. Yeah, so just that was how it was meant to be, just a basic introduction so that you try to picturize how it works, how it looks like, and how you are going to encounter neural networks. So my last section, which will just take me not more than 5 minutes, is just to introduce you to...
Dennis?
Yes?
I have a question.
Sure.
Do you have an optimal point where we should have the noise, or we should increase the noise to?
No, there's no optimal. That's why I've talked of trial and error. You'll keep either, if it's overfitting, for example, you'll have to introduce to increase the noise so that it trains the model more. But if it's underfitting, then you reduce, not probably, you reduce the noise. You will keep checking the performance. So there's no optimal, there's no one size fit for all. You'll keep changing different hyperparameters, even the noise. You either increase, especially if it's overfitting, it means you need to, it cannot just give you a perfect model, 90% accuracy, no. Then there, you try to increase the noise.
Oh, I'm thinking it's in terms of telecoms, we have a parameter called noise to signal ratio.
Yeah,
so the more the noise, the more the signal, the less the signal strength.
Okay.
Yeah.
Okay. That's a quite practical, and it's something maybe I would side chat and then think along that line. I've not tried to think in terms of telcos, but that's a good use case. Okay. So before I move to the last stage, is there any other question?
You've said that the noise is like an irrelevant piece of data, or
yeah.
So it's supposed to distract the neural networks from how does it?
No, it's supposed
so that you can get improve the load.
Okay, so the noise in essence, like I've said, it's almost irrelevant, like randomized data that you increase in order to improve the performance of your model. The fact is that when you train your model using more data sets, depending on the complexity of your model, the model performance will improve. Okay? Yeah. So when you increase the noise, it's supposed to also reduce overfitting. And when it reduces overfitting, it will not give you a false accuracy. It will give you a real accuracy, optimal accuracy. So that's where the aspect of noise comes in. Noise in quotes. So it's simply just increasing data, but now it's not really data that you already perfectly selected for your performance. Okay.
Oh yeah. Okay, I get it.
Yeah.
Thank you.
Sure.
So Dennis, for the next week session, they can look at this in a Python notebook, the same simulation.
Okay.
And then we can prepare some notes on these definitions of noise, ROC, AUC, just so they can refresh themselves. Yeah.
So maybe I can just spend like 5 minutes only, or 2 minutes, just to.
No problem. Just go ahead.
Yeah, to collab and the back end, and then that's it.
Yeah, we still have time, so just go ahead.
Oh, okay, thank you. So this is just an example of the use of CNN in object detection. Don't worry so much about the codes here. I just want to introduce you actually to this platform that is Colab. And Colab is simply a document, executable document, or rather cloud format of Jupyter Notebook. This is where you can be able to host your notebooks on your drive. So when you are done, let's say with this one, you just click on Control-S, and then you save to the cloud. But if you want to download, for example, let me just show you. You want to download it as a Python notebook so that maybe you share with somebody who has no internet access, because this is cloud-based as opposed to Anaconda or Jupyter Notebook. So you just download as that, and then you get to share the same. So this one is just a cloud format of where you can host your Jupyter Notebook. And this is interesting because you can be able also to switch and use it in R at the same time. It's not just limited to a Jupyter notebook. So just like how a Jupyter notebook looks like in Python, Anaconda, that is the offline one, you can be able to add a code, that is add the cell. If you want to code, you can be able to add the cell. Then if you want to add a text, which, who can tell me in text, what do you do in Python, in Jupyter notebook? What do you need to change? So you change from code to markdown if you want to do text or maybe heading. Maybe somebody wanted to say, but it's cool. So if, let's say you want to edit and maybe cut a cell selection, like I'll just cut that particular cell, you select this cell, then come here and you cut it. Maybe not that way as well. You can come here and just delete this particular cell. Let me just add another cell. Come here, and then you delete that cell. If you want to add a cell downwards, click on that on the lower part. If you want to add another cell on the upper side, you click on that particular one. And then an important thing that you should also know, it's, let's say you want to upload a notebook. So as Timothy has told you, today a lot is switching. When you want to go for a data science interview, nobody would really be interested. They would want to know what is in your mind in terms of business value using data for data science. But then you need to have a repository whereby you've stored your previous work, you've stored the previous code developments that you have. So you can just come here and then you connect maybe to GitHub, and of which I presume maybe we should probably be having a GitHub repository. So you can see my repository. I have AutoArima, then I have linear regression, then I have employee channel. So if I had to go to an interview today, then I'd need to show my GitHub account and different repositories that I have. You see, when you click on it, it takes you to the typical Jupyter notebook that all of you are familiar with, and different cells that you do have. So a typical case here, you all know what the importance of this. You import the different libraries, pandas for numerical data analysis, sorry, NumPy for numerical data analysis, that's why it's numerical Python, pandas for data manipulation, and then we have matplotlib for visualization. And then the sub-library of it is pyplot. And of course, you now import your data set. I've decided to rather you load your data set. I've decided to name my data set as data, then pd.read_CSV. If it were Excel, then it would read as Excel. Then you change here as XL, SL. Then right here is a section whereby let it just load. You need to upload it to Google Colab first. If you've downloaded your dataset, you should come here. Then it will take you back to your local computer. And then if your dataset is in downloads, for example, I was trying to locate this descriptive statistic. If your dataset you've downloaded and download, you just come here. Then when you click on it, for example, even this, it should be able to appear here. That is if it is a typical case of this airline passengers.csv. And then you visualize your data set by just saying data or data.head. Yeah, as you continue. So just the most important thing was for me to introduce you to Colab and help you familiarize with it. I know that it's just a typical Jupyter notebook, but it's just hosted on cloud. And you can be able to access your work. You can be able to leave it there and continue. You can be able to copy it to Drive, so that you save it on your drive. Maybe I can just open my drive. You see what I've already saved as my previous work or content that I have so far. So I think you've just seen a few minutes ago, I opened AutoArima, and here it is. It can be reflected for quick access. Then some machine learning questions, and then different Jupyter notebooks that you have, or collaboratory notebooks that you have. If you want to access it, just click on it, and then you open with Google Collaboratory, or you click on Google Collaboratory. So of importance, you need to know that you need to have internet as opposed to Jupyter Notebook, whereby it's basically offline. So I believe, Tim, that brings me to the end of my presentation, unless I have any questions from the team.
So Dennis, you're saying you prefer to use the Google Collaborator as opposed to using the Anaconda?
Yes, myself, the moment I switched to Collaboratory, I can't remember the last time, because you see, this one, the local one has a lot of dependencies. You need to carry a local machine, maybe, you know that very well, because this current machine that I have, I do not even have Anaconda, but the other machine, I have Anaconda, so I can access it offline or on premise, and then this one I can access it on cloud, that is via Drive. So I largely prefer using this. If I'm going to a board meeting and I don't want to carry my machine, but I want to demonstrate a few visualizations, I just quickly go to my Google account, then access it, Gmail account rather, then access it, and then go to Drive, access the particular notebooks that I want to demonstrate or visualize, then run through them. I find it to be with much ease and a bit comfortable. So it's easy actually to switch from Jupyter Notebook to Colab.
Yeah, there is also the aspect of the GPUs. So Google Colab has embedded GPUs. Yeah, so you realize when you're doing neural networks and some models, there'll be Jupyter Notebook actually hangs. Yeah, so you can use both in transition. Yeah, so we'd like to encourage you to start now trying using the Google Colab. So Dennis, when you're preparing the notes to be sent, we will put a link where you can just click and go to the Google Colab.
No problem. No problem.
Yeah.
I think.
And how do you compare that with Kaggle?
Kaggle is just Kaggle is just a community whereby you can access data sets, you can access different works and everything. But then Kaggle does not have pre-installed libraries. This one has pre-installed libraries. Kaggle is actually, if you want to run those.
Kaggle is for data sets. So you'll find data sets in Kaggle.
Yeah.
The kernel is limited.
Exactly. So Tim, I think that's what you're just mentioning here. Let me just show you. Right here, you can be able to change from GPU or TPU, because we have TensorFlow 1, TensorFlow 2, then switch it depending on the amount of data set you have and the speed or rather the processing speed that you desire. Thank you.
Maybe, Dennis, you could share the link to access this.
Okay, what you do, I think all of you are on your machine, just type Collaboratory, just type Collaboratory or Colab.
Colab.
Oh, I can still share it, but just type Collaboratory. Let me just share on the chats. Has anyone been able to access the same? I don't know, I can't see my chats.
Collab.research.google.com.
Exactly. Just open it and show us your screen. Let us see from your side. So that's the link. Are you able to share?
Yeah, I can share.
Okay.
I don't know if you're seeing my screen now.
Yeah.
Can you see my screen?
Exactly, that's it. And then just go back. I just want to show you something as I wander.
Go back?
Yeah, just right where you are, but I want to see the whatever is at the back. Just click on the.
I cancelled. Okay. Here?
Yeah, just cancel, exactly. So even as you look at Collaboratory, it's already self-instructed. So I just needed to introduce you to the interface, but it's already self-instructed. There are different resources here. For example, click on data science. It's already demonstrating a few examples of data science models, what you need to know, and different resources that you do have. However, this is not custom made. What we now train and teach is what is custom made, and we'll be using unique data sets as opposed to what is already here. But if you want to get more information about Colab, then it already has, just like we have a documentation in Jupyter Notebook. Okay, thank you, Moses, for that.
So for example, if I wanted to get a Jupyter Notebook, it's you can just type here.
You want to open a new?
Yeah.
Click on File.
Oh,
then
okay.
Open Notebook. Sorry.
Okay. Okay.
And then this one is dependent on your connectivity.
Okay. Okay.
Yeah, if it's not a good one, then it would also be problematic. I think now you are so familiar with this. It's just the typical Jupyter Notebook, right?
Okay. 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 That's okay. I think from here we are okay.
Okay. Okay. Okay. Thank you. Okay, team, I think on my end, I'm good.
Okay. Yeah, right. Otherwise, thanks. Thank you all for making time for today's session. I think this is the best that we will have for this class. As I promised you, we will be doing business applications and some live code and using pre-existing resources. Because at this level, it's really strategic. We don't expect you to be going to wrangle a lot with the data like we did in the introductory module, but we'll be doing mostly testing of business hypotheses and choosing different models to apply and focusing more on the recommendation engines to be built for the business applications. So we look forward to your input, prepare those case studies, use cases, engage us a lot more, because at this level, it's really about what you're heavy lifting to have value for your day-to-day business operations. So have a restful weekend. We'll share these materials via email on Monday. And yeah, so we'll also give you a call within the week just to see how you're progressing. So have a restful weekend.
So I'm giving you guys access. I've seen the request for access. I've given you access. Millicent and Victoria.
Koirini, and have a restful weekend.
You too.
You too. Thank you.
Thank you.